Alright, we've zeroed in our table, and we've got a good alignment right here with our hole to follow with the drill and reamer. Now, instead of just letting this hang here like we did when we pushed in the tool that just came down and rest on this here that was guided with the other thing, we're going to be creating a drill line, and we just want to make sure there's absolutely zero flex in here. So we're just going to lightly put our screw jack under here so that we know we're 100% solid there, because we're going for a finished cut on a bore here. At least hopefully we're going for a finished cut. Alright, we're going to go ahead, and what we're doing is we went ahead and put a brand new edge on our 55/64 drill bit, and then we put a flat right against both of these cutting edges here of the flute, so that we don't grab as it's going in. And what we're trying to do is follow that hole and create a size to where we'll be able to just chase down through this with the reamer. And I have a straight 7/8 reamer. We cut off the end there so that we can grab this, and we're going to run this reamer down through there, and then we're going to mic up the hole, and we're going to see if we can come in with a close enough fit for our bushings doing it with this method, and then we'll continue on with the rest of the job after this. So, and we're going to go a little bit at a time, and then we're going to poke the reamer in just a little bit, and we're going to verify before we actually go all the way through with this. And we're going to let the auto feed do this. All the way through. Alright, I'm going to raise this up and pull the bit out. We're going to go ahead and mic up the hole just to see what we got right now. .866. .862 down in there a little bit. So up the top it does get probably because it was just entering there. No, 60, 63. Let me just check it again. Maybe I was just measuring it funky. No, it is like 864 up here at the top. We're well within the realm of a nice ream now. That'll give us about 10 thousandths total, 5 per side on the ream. Alright, we're going to slow this thing down. Alright, let's bring this down a little bit. Alright, we shifted our gearbox into the low end there. And you can see we're nice and slow. Nice lube all the way around. Alright, we're going to poke this in a little bit. We're going to see if we can get a nice tight ream on this. We went in about 1/4 inch. Feels good as far as the surface going. Definitely is an interference. I don't know if I can get a decent snap on this, but we can give it a try here. Alright, and See what we got here. It says it's 876 is what I'm reading here. And on the bushing here, what do we got? 0.877. So we got 1/1000 press fit there. All right, let's go ahead, bring this down. Let's go through the hole and see if we can have a successful ream with this reamer here. Main thing about reaming is slow and keeping the flutes clean. This is not a brand new reamer either, so that's why I was really kind of iffy on it. Not taking any chances, making sure that it's clean and clear and no galling. She gets firm when she's all the way down in there, so. Alright, we're all the way through. Not a bad feel. Looks pretty good. Alright, see what we got for a dimension down in here. Now that we got a good pull over. And I got 876 and a half. She wants to stick right there. I think we're going to have something workable, and I can always pass a little bit of a little flapper in here. She's going to take another measurement here. Same exact thing. I think we got a good hole. Alright, we're going to go on to our next one. And the reamer feels good. I don't have any galling on the end of it, what I was kind of worried about. Alright, so now we got this loose, so we're bringing this around to line up our next one here. And we work a little bit about rotating the table, just like we did before here. Okay, and then we tighten up our plate, tighten up our table. There we go. Alright, now we're happy. Okay, and we tighten up the screw jack under here, just so we got pressure. Now our first time we ran this drill bit, it sounded a little rough when it first hit in the hole there, and I wasn't happy with that. So I'm going to go ahead. I want to speed it up a little bit, but not so much. Alright, that looks pretty good. And we're auto feeding this as well. Same thing. 876 and a quarter, 876 and a half. Gonna be nice. Little chamfer there. Alright, we're all done with reaming the 4 holes in this one. I have something I'd like to share with you. One of my my colleagues at North Star Propeller, when I was working there, had a brace, and he mounted a chuck on it, and he, you know, you could run drills, you could run all kinds of different things in it, but most of the time he kept a countersink or chamfer tool in it. And finally I had found my own and created the same thing and got the right chuck fit up on here. And of course you can also do taps and a couple other things too. Of course, you know, you got to be pretty slick with a tap without breaking it. You have full ratchet capabilities on one of these braces, and reversing, just depending on what you got. Sometimes you could be in and you want to do a hole and you're up against the shoulder and you have to go so far and then you have to back up. Well, if you put enough downward pressure or hold this with your hand, you can go ahead and get the chamfer. One thing that's nice about this is sometimes you go through your steps and all of a sudden you pull a part out and you go, oh man, I forgot to chamfer that. Or have you ever been in a machine and the chamfer is just like, it just really digs in or grabs? There's pros and cons to the whole thing. The thing I want to share is the brace and the chamfer or the countersink is a handy tool to go around and just light. All you want to do is break that corner right there so that I know that that bushing is going to go in there. There's a real tiny radius right there, and I want to make sure that the thing is set all the way down in there. So I'm going ahead and taking this and giving a couple revolutions here so that I can break that edge in there. And then I know that those flanges will set down there nice and tight. And physically look at each and every one of them, make sure that you did go enough, and eyeball it to the individual radius that I got here. Alright, and then this of course hangs on the back of my collet rack right on the Bridgeport. So that's why in some of the videos you might see an old brace hanging on the Bridgeport. That's kind of where I keep it. It's handy. And that's where I use it a lot. So you go ahead and you do a lot of drilled holes or whatever, you pull a part out, and sometimes just a quick brace and a couple rotations there, you can get the quick burr or the break the edge just like you need it. Alright, I got to flip this over, and of course I'll be going back to this. Alright, we're coming down to the last two holes, and just like anything else, when you really have done quite a few of them, usually by the end, you're an expert pretty much of the process or the procedure that you're going through. And you know, it didn't take long to get used to doing the rotation to get this in and out kind of thing. Motion going on. Instead of a straight Y and X axis here, you got two oscillating circles to do your alignment. So after a while you get used to it, and also there's a certain amount of sag and play that was down in the column and stuff, and kind of the reason why I didn't go through with the spot facing and then ream it. Of course that can only be done on the second side because the tool itself for creating the counterbore was using the original hole that we created with the end mill. So that would have to be done on the second one. Anyhow, let's go ahead and we're going to get this in position here. And I was learning how to get it real close. We know about how much it actually takes to draw in by your tension on everything here. And there we go. Alright. In some of the video there, I was giving you an idea. I wasn't cutting it or speeding it up because I wanted you to kind of know actually how long it actually takes and stuff like that. It's not that this is the fastest way. This just happens to be a way to get her done. So we run the drill bit down through and we let that feed on auto feed. The only reason why we're doing that is we don't want to suck the bit in there and damage the hole. So we wait for it. You know, we're only working on 16 of these holes here, and I have to laugh because the comments come in on the amount of bearings. Well, most of you that just come in and you didn't watch the original videos on it, you have no idea that there's another set of components that take 4 more bearings each, and there's 8 of these things here. So that's where the 64 bearings come into play. It's not just these castings here, it's the next set of castings that we'll be playing with as soon as I get down to these 2 holes right here. Alright, so we're almost through on this hole here. Okay, now the reamer, we go ahead and we hand feed this in here, and we just keep it lubed up, and we're going about half an inch at a time, and then come out, we clear out the reamer, move it up, we go in for another half an inch. We bring it all the way down so the reamer's full. We contact it through the whole floor. And we're set, we're ready to go for our next one. Alright, pull out the screw jack. Alright, we're rotating that back and then this in. Alright, like that? Yep. Alright, a little chamfering, and I found that just leaving it up here on this jig lets me get a nice purchase without having to bend over on the floor. And also, if I go like this and flip this over and let it hang on the table there, I can get the other side with my brace and chamfer tool. And a little blowing up. Okay, all of our parts here are now ready to have the bearings pressed in, and we're going to be doing that, but we're going to go ahead and we're going to start setting up, and we're going to take care of our links, and we're going to create the new width and the new bore for the bushings to be pressed in on each one of our links. Alright, so let's get this out of the way, and we're going to start setting up the Bridgeport to handle these.